In this video, I'm going to give you an introduction to factoring. So factoring is, in essence, the opposite of the distributive property. Okay, so when we distribute, we are distributing and multiplying one or more terms into one or more terms. In this case, we're distributing and multiplying 2 times x squared, 2 times 4 to get 2x squared plus 8. What we're going to start doing now is being given 2x squared plus 8 and having to go backwards to get 2 times x squared plus 4. What we're going to do is talk about how to factor out the greatest common factor, GCF. So I want to remind you what GCF is. Okay, the greatest common factor is the largest number or expression that two numbers or expressions can be divided by. So here's a very basic example. Greatest common factor of 18 and 24 is 6. That's the biggest number that they can both be divided by. You probably used greatest common factor most recently when you learned how to simplify fractions. Okay? Remember when you're simplifying fractions like 18 over 24, you have to figure out what the greatest common factor is. In this case, it's 6, so you would divide top and bottom, numerator and denominator, by 6, and get 3 over 4. So what we're going to be doing is taking out the greatest common factor of expressions. So each of these you're going to be asked to factor. Okay, so it would say factor out the greatest common factor. So let's figure out what the greatest common factor is for our first one right here. So we have 2x plus 4. Okay, so we got to find a number or an expression that will factor out of both terms. So what will factor out of 2x and what will factor out of 4? Okay, so the first thing that I notice is that both of these numbers are even. That means that I can definitely divide them both by 2, and that's the biggest number that I can divide them both by. So I know that my greatest common factor is 2. Then I look at my x's. Okay, only one of them has an x term. That means I can't factor it out because it is not a greatest common factor of both terms. Okay, so my greatest common factor in this one is simply 2. That means that I can factor out a 2. Now, what's left in the parentheses is what I have after I divide both terms by that greatest common factor. So if I do 2x divided by 2, I get x. I do 4 divided by 2, I get plus 2. To check yourself, you can multiply it back out. You would get 2x plus 4. That is factoring out the greatest common factor. So let's look at the next one. 3x squared plus 6x. So the first thing that I notice is that I can factor out a 3 from both of my coefficients. So I know I can factor out a 3. But look at this. Both of these have an x term. That means that I can factor out at least one x. So here's the kicker. I can factor out the lowest amount of x's that one of the terms has. In this case, 6x has only one x. Okay? That means that I can factor out one x from both of my terms because this one has 2. So my greatest common factor is not just 3, it is 3x. So I'm going to take my 3x and put it on the outside. So now I divide both terms by 3. Okay, so 3x squared divided by 3. Let's go ahead and do the x at the same time. So 3x squared divided by 3x. The 3's are going to cancel out. What's going to happen to the x squared over x? Well, one of the x's is going to cancel out, so I would be left with an x on the inside. So now look at this and you can check yourself. We know that 3x times x would give me that 3x squared that I started off with. Okay, 6x divided by 3x, the x's would cancel out and I would be left with a 2. And finally, we have 4x squared minus 26x to the 5th. So again, I'm going to look at my numbers, and I'm going to look at my x's, okay? So on this one, the greatest number that I can figure out is 2, okay? I can't factor out a 4 because 26 will not divide perfectly by 4. So I know that I can factor out a 2. And look at my x's. This time this one has an x squared and this one has an x to the 5th. Okay? That means that I can factor out the lowest number of x's that I have. I can factor out an x squared. That means I'm going to be dividing these by 2x squared. Okay? So 2x squared goes on the outside of the parentheses. I'm left with just a 2 on the inside here. Then minus, let's see, 26 divided by 2 is 13. When you are dividing x to the 5th and x squared, when you are dividing, you subtract the exponents. Remember when we multiplied, we added the exponents? Well, when we are dividing, we subtract the exponents. So you would have 13x to the 3rd. So check yourself, multiply it out, gives me 4x squared minus 26x to the 5th. See how we just added those two numbers back together? That's why we subtracted them in the original problem. Now sometimes you get more than one variable in here. So looking at this problem, I know that for my number I can factor out a 2. I have one x that I can factor out. That's my lowest number of x's. I have one y that I can factor out. That means I'm going to be dividing these by 2xy. Okay, so I got my 2's that are going to cancel out. I've got one of my x's that is going to cancel out, and then my y's are going to cancel out. So that ends up with just an x on the inside. For my 6xy squared, I know I'm going to end up with a 3, so minus 3. My x's are going to cancel out completely. Then my y's, I'm going to be left with 1y, so 3y. Now, check your work, multiply it. I get 2x squared y minus 6xy squared. That was what I originally started with. And now again, I've got 3zxy minus 4zy squared. I can't factor out a number of this one. I can factor out a z. They have that in common. Each of them has one z. I can't factor out the x because this one is the only one that has an x. I can factor out one y. So the outside has a z and a y. So I'm going to divide by zy. So I'm going to be left with 3x for the first one, because the z and the y cancel out. Then I'm going to be left with minus 4y on the inside. The z's are going to cancel out. One of the y's is going to cancel out. So check my work. I get 3zyx minus 4zy, which is back to where I started. And that is factoring.